Hello everyone, I'm Andrel and I'll be sharing about my final year project on personality prediction on the MBTI model. There will be 5 parts to this video: the introduction, followed by exploring the data, methods used, a prediction tool, and finally the conclusion. MBTI in full is known as the Myers-Briggs Type Indicator. There are 16 different personality types and 4 dimensions on the model, each represented by a character. For example, INFP will signify an introverted, intuitive, feeling and perceiving individual. The MBTI model is used in job interviews, recommender systems, and more. Some other personality models include the Ocean and DISC models. Currently, questionnaires are used to determine someone's personality on websites such as 16personalities.com. However, because users are able to see the questions, there can be a biased outcome where answers will be given based on the MBTI type they want to be perceived as, especially in job interviews where fabricated answers can be given to be more likable by hiring managers. Other than a biased result, some data quality issues is also present in online surveys. Therefore, this project aims to mitigate the shortcomings faced in online assessments by experimenting with deep learning techniques for an automated personality prediction, along with a prediction tool on a website which will be shown in the coming slides. The tool can also allow users to conveniently predict their personality as an alternative to questionnaires. There are 2 datasets used for this project. One is the Personality Cafe forum dataset, while another is a dataset with Reddit comments in 2019. A series of steps are taken for data cleaning on both datasets, including the removal of URLs, stop words, and lemmonization. The clean datasets are shown in the figures on the right. After data cleaning, an exploratory experiment on machine learning models is conducted to compare the accuracies of both datasets. As there are 16 different personality types, it increases the difficulty in high accuracies, which explains the best being at 27% on logistic regression. With higher accuracies on all the machine learning models, the Personality Cafe dataset is chosen for further analysis and classification. When taking a closer look at the labels, there is a huge imbalance of classes. INFP has the most data at 1.8k rows, while the lowest is ESTJ at only 39 rows. Even after splitting up the labels into 4 dimensions, a class imbalance still exists for some dimensions, especially the IE and NS axes. As seen previously, there is a pertaining class imbalance issue in the dataset. As a result, 2 kinds of classification were used. The multi-class classifier trains all 16 MBTI types in the model, whereas the binary classifiers train on each axis. For example, IE classifies between introverts and extroverts. Therefore, there are 4 binary classifiers and 1 multi-class classifiers trained on each method. Experiments were conducted on 6 different methods, with neural networks, multitask learning, and more. Most methods are using an 80-20 train test dataset split, which will be discussed in the following slides. Firstly, for machine learning, bag of words with LDA known as latent Dirichlet allocation is used for topic modeling on 4 different topics. Following that, to address the class imbalance issue, techniques like SMOTE and random undersampling were used for training on 3 machine learning models. However, the results obtained were better without any class balancing techniques and therefore not used for further personality prediction approaches. Through 16 different ML models to be used as baseline models, the best results came from logistic regression and naive Bayes. After machine learning, the second approach considered is to apply transfer learning on transformer-based models like BERT, DistilBERT, and also zero-shot learning on the pipeline. Through the fine-tuning of the pre-trained models, DistilBERT performed the best in this experiment, whereas zero-shot learning did not work as well, possibly due to the difficulty of evaluating personality through a zero-shot model on the natural language inference pipeline. Next, 6 different neural network models were used for training on the dataset. Each of the 6 models used glove embeddings with different model configurations, such as a sigma function and binary cross-entropy on the Keras model for the 4 MBTI dimensions. Dropout layers are also added to prevent overfitting of data. The best results came from a CNN model for both binary and multi-class classification. However, due to the class imbalance issue, the MBTI types with more data had stronger predictions, as seen in the confusion matrix on the right with lighter shades of color. But for those MBTI types like ESTJ with less data, it is difficult to accurately predict personality. Using a stacked ensemble approach, the top 3 neural network models for both binary and multi-class classifiers are combined and trained as one model. The neural network models previously used non-independent data without a holdout dataset. As the personality types like ESTJ only had 39 rows, the training was previously done in a manner to maximize training data, particularly for personalities with a small number of rows. A new data allocation was used on ensemble learning experiments with controlled random states for preventing less overlapping of data. The models performed better individually, possibly because of weight-based classifiers with accuracies lower than 50% and lesser training data with the new allocation used. The details of the ensemble learning approach is discussed in the next 3 slides. These illustrations show the new allocation of data with a 3-way split and the use of controlled random states to ensure that the data does not overlap as much in those classes with significantly lesser data. Using a stack ensemble method, the top 3 models CNN, LSTM, and GRU were retrained with the new data allocation and controlled random states, and then combined for the multiclass classifiers. As there are 4 dimensions, the concept of a multitask ensemble method is adopted for the binary classifiers. Apart from retraining the top 3 models from each dimension via LSTM, CNN, and GRU, the 4 stack ensemble models are combined using a string concatenation to derive a collective MBTI type. Next, let's move on to multitask learning. In this experiment, the high parameter sharing technique is used. There are 2 categories considered during training. For the first one, each MBTI dimension will represent 1 task in the model, where you will have 4 tasks. Another category combines the 16 MBTI types, sentiment, and subjectivity. To train the 2 categories of tasks, an MLP model and a CNN model with glove is implemented. The architecture of the multitask CNN model is shown here. After data cleaning, labels of sentiment and subjectivity tasks are added with SenticNet and text block. There are rows which require additional labeling, which will be shown in the next slide. After labeling, the data is fed through the glove CNN model, where the outputs will signify each task category. As mentioned in the previous slide, additional labeling is required for a few rows of data due to some issues. For sentiment, some rows were undetected on SenticNet as the server was unavailable during the time of processing. Instead, those undetected rows are processed using NLTK's Vader. And as a comparison, there is a huge similarity of 82% between SenticNet and Vader results. The multitask dataset for MBTI and sentiment is shown on the left. As for subjectivity, there is a single row of data that is labeled as neutral. The row is manually relabeled as subjective as it contains words like suppose and must. If a single row is left as a neutral class, there will be issues during training as there is only 1 row of data and not usable for validation. Hence, there are 2 classes instead of the original 3. Lastly, the final approach used is a hybrid self-attention model. In previous experiments, Distilbert had the best results using transfer learning, and the pure glove CNN model performed the best on the neural network. Using a hybrid of both models, Distilbert embeddings will be used on the CNN model. And in addition, a self-attention mechanism is applied to help retain semantic information. The illustration of the hybrid model is shown in the image below. However, after training with both models, the glove CNN model had better performance than Distilbert embeddings with better accuracy scores and MBTI types predicted. This could mean that the glove embeddings are more suitable for this dataset. Next, I'll be sharing about the prediction tool. After all the experiments, an MBTI prediction tool was designed with Streamlit to allow a more cohesive user experience of the model's train. This is also to provide an alternative solution for challenges and biases faced in online personality assessments. There are 2 pages within the application. Firstly, there is the prediction tool to predict personality based on user input. As the CNN model had performed the best for multi-class, 2 models are deployed to provide users with an additional option. Apart from the Personality Cafe dataset used for all experiments, the previously omitted Reddit dataset was used here after training on the same model configurations. After receiving a text input from the user, simple text processing was applied with the removal of digits and punctuations. The texts are then tokenized and evaluated to produce an MBTI result, along with a sentiment and subjectivity of text. Although there was a multitask model implemented for those 3 tasks, the model did not perform as well as a pure prediction neural network model, and hence the multitask model is not deployed here. Let's take a look at the MBTI prediction tool. Lastly, moving on to the conclusion. The project has covered 6 different approaches for predicting personality, with the MBTI prediction tool designed. Due to the class imbalance issue, it is difficult to learn efficiently for classes on polar opposites in value counts as seen in INFP and ESFJ. However, as the MBTI personality model contains 4 personality dimensions, it is used as an option for analysis and classification to attempt to address the class imbalance issue. From the results, we can understand that the fine-tuning of a pre-trained distillable model had produced the best accuracy scores as binary classifiers. The multi-class models, on the other hand, was based on the GloveCNN neural network model. Overall, the models had better performance than the random guessing of MBTI types at 6.25 accuracy. Multitask learning has showed that learning several tasks simultaneously can increase efficiency and save time, where adding more classes to the multitask model had obtained similar accuracies. Through the hybrid CNN model, glove embeddings are more suitable than distillable embeddings for this dataset as there were diminished results. In addition, future work can consider multitask learning with other natural language processing tasks and other MBTI labeled datasets. That brings us to the end of the video. Thank you for watching.